Next, we are considering the distribution of bending moments. The bending moment is determined by the product of force and arm length. We may start by considering the amount around the origin O, which is the easiest to understand. Since the amount around the origin is the product of the load P and the arm length L, this is the bending moment acting around the origin O. We are also considering the situation of slightly shorter arm length. We now focus on the bending moment at point B on the x-axis. Since we are pushing the beam vertically at P from the left, we will have a bending moment that is determined by the product of the load and the arm length. The length of this arm is the length of the beam, L minus x. So, the magnitude of the bending moment acting on this point is given by the equation. Now, this illustration shows the bending moment that is generated in the beam. This moment is bending the beam downward. In the previous argument, we have defined a bending moment that bends a beam downward into a convex shape as positive. Following the definition, this bending moment is negative. So, the bending moment at the position x on the beam is the product of the force and the length of the arm, as given by the equation. Now, point B is defined as a point on x-axis. As x changes from 0 to L, the bending moment is given by the same equation at all locations. So, the bending moment that occurs in this beam can be expressed by this equation. This is a linear function of x. This linear function defines 0 when x is L and then minus PL when x is 0, as the diagram shown here. This diagram is called bending moment diagram, BMD. We used the abbreviation BMD in the following instruction. Please remember the BMD together with SFD mentioned before. The BMD of the beam in this problem is a linear function. As the beam in this problem, a beam fixed at one side and loaded on the other side are called cantilever beam. In this case, the cantilever beam is exposed to a concentrated loading. As examples of a cantilever beam, multiple loads or distributed loads may be applied to beams. In any case, remember that a beam that is fixed on one side and subjected to loads or moments is called cantilever beam.